Okay, we want to find the nth root of complex numbers today. Today is not easy, so do your best. W sub k is equal to r to the 1 over n times the cosine of theta plus 2k pi over n plus I times the sine of theta plus 2k pi over n. That's our formula. That's one that you're going to want to write down for your notes for your test. Nth roots of complex numbers. That's the formula. What does that mean? If you look at example 6, it says find the third roots of negative 27i. So again, if I just ask you, what's the square root of negative 4? 2i. Well, what if I ask you the square root of 2i? What if I ask you the eighth root of 2i? What if I ask you the cube root of 2i? That's what we're dealing with now. How do you find roots of complex numbers? And namely, we're going to look for the third roots here for this example. And so n is 3 because it's your third roots, okay? Third roots, it means, for example, the cubed root of 8 is equal to 2 because 2 times 2 times 2 is 8. So that's what we're trying to do. We're trying to figure out what times what is negative 27i. And here's the piece that we need to understand is you guys know where we get n, right? But you don't know where we get k yet. We haven't defined k. K is equal to 0, 1, 2, 3, n minus 1. And so what that means is one number less than n. So as you look at this example here, find the third roots of negative 27i. What is k going to be? If we are looking for the cubed root, k will end up being at the very end 2. And so we end up finding in this situation third roots. There are 3 roots that we will find that are cubed roots. And we choose the numbers 0, 1, and 2. How do we get those? Because those are the first 3, but namely, k is equal to n minus 1. So we choose those first 3. So we don't go all the way up to 3. We go 0, 1, and 2. All right? So just follow the formula, and let's see what we get. See if this makes sense. I have to start with w sub 0. Yep, we'll do w sub 0, we'll do w sub 1, and w sub 2. Now we'll give us our 3 third roots of negative 27i. Question, Whitney? Because there are 3. It's a third root, and we're going to find 3. Then you would go, yeah, so if there's 4 fourth roots, we would go 0, 1, 2, 3. Okay? This takes a long time. So on the test, it might be more likely to give you the square root. So with my calculus class for their next test, it's so long that I've decided to just make it all open note, which they were all excited about. And I said, hey, the last open note test I gave you guys, you told me it was the hardest test you've taken in your life. So I said, and it's going to be over the course of 2 days because it's going to be that hard. So then they started to get a little anxious. And I said, well, I don't know what to do. I can't put, it takes so long to do these problems. What do you want me to do? So anyway, that's where we're at. We only have 2 sections that we're going to cover here, though. This section and then another one. Now, what we have to do is we have to find w sub 0. And in order to find w sub 0, the first thing we need to do is we need to take this number and we need to convert it to trig form. So your first question on the test will be, can you plot a complex number? I hope you can plot a complex number. Your second question will be, can you convert some of this stuff to trig form? Well, we want to take this number, which is 0 minus 27i. We want to convert it to trig form. In order to convert to trig form, I need two things. What do I need? R and theta. So we'll try to find R, and we'll try to find theta. Now I find R by going the square root of a squared plus b squared. So R is equal to the square root of a squared is 0 plus negative 27 squared. You know what that comes out to be? 27. And then when we find theta, theta will be b divided, tangent of theta is equal to b divided by a, right? So tangent of theta equals b, which is negative 27, divided by a, which is 0. What's negative 27 divided by 0? Undefined. Where's tangent undefined? 90 or 270? Which one am I talking about? 270. Very good. And so that's 3 pi over 2. Question, ask it. I don't know, it's 270? Okay. If you look at your graph and we were to plot 0 and negative 27i, we're over 0 and we're down 27i. So you can see right away, if you just plot this right away, you could tell, well, yeah, that distance is going to be 27. That's going to be my r. And my angle is going to be right here, which is 3 pi over 2. So the first thing I do when I see the problem is I think of it graphically. And so right away I knew it was going to be 27 and 3 pi over 2. Now, the formulas work out to tell you the same thing. But, you know, if you knew to do this on the test, you could do it. You wouldn't have to show all that. I mean, you could just say, well, look at what I got. So that makes sense. So now I can write the trig form. So negative 27i converts to r, which is 27, times the cosine of 3 pi over 2 plus I times the sine of 3 pi over 2. Right? So I've got the trig form. Now it's time to use it. And just to pause for a second, you guys, understand what you're doing right now. You're finding a root of an imaginary number. Is this anything you knew how to do before today? No. So this should not necessarily be just obvious, and understand that you're finding something you have no idea how to do yet. So this is pretty neat. Because the radius is positive 27. Okay. Oh, Taylor, they're good questions. Keep asking them, okay? All right, so we go to work. W sub 0 is equal to 27, which is my R. I just followed my formula. To the what power? 1/3. Because it says 1 over n, and n is the root number that we're finding. So third root, so 1 over 3 times the cosine of theta, which is 3 pi over 2, plus 2 times k, 0, times pi, divided by n, which is 3, plus I times the sine of 3 pi over 2 plus 2 times 0 times pi, divided by 3. Ugh. Now, this looks bad. It really isn't. There's a easier way to work through this. Let me just show you, okay? Let's simplify this. Not too bad. 27 to 1/3. 3. Now, follow me here, everybody. 3 pi over 2, right? You don't have to write this down. Plus, what's 2 times 0 times pi? 0. Or I'm just writing this down, 0 pi over 2, right? Right? Because that'll help later as we're doing other stuff. Divided by 3. What's 3 pi over 2 plus 0 pi over 2? 3 pi over 2 divided by 3. 3 pi over 2 divided by 3. Or 3 pi over 2 times 1 over 3. You just get pi over 2. So I'm going to refer back to those steps when we do our others. So all we have is pi over 2. Cosine of pi over 2 plus I times the sine of pi over 2. You can look at your unit circle sheets if you want. What's the cosine of pi over 2? 0 plus what's sine of pi over 2? 1. So 1 times I is I. I distribute that 3 through. What's 3 times 0? 0. What's 3 times I? 3I. Now, this is where we started to lose things second hour because people got kind of angry when they saw that. They said, well, Mr. Gens, I could tell by looking at negative 27i that the cubed root would be 3i. They said, I could tell that. And I said, yes, but you can't figure out the other two. Trust me, when we do the other two, they won't be as obvious. They will not. Because people are like, why do I have to go through all the work? I could just see 3i. I said, trust me, you won't be able to do it with the others. What does that mean, 3i? What that means is if I take 3i times 3i times 3i, I will get what? Negative 27i. So we've just found a cubed root of negative 27i. That's one of them. There are 3 of them. Let's find the other 2. Yes, you may have to take out a sheet of paper and attach it and put a reminder at the bottom to say, move on to next page. Oh, there's a backside? Look at that! What a good guy I am. Have to remind myself every once in a while. W sub 1 equals 27 to what power? 1/3, which is 3. So we know we're going to have that every time. Times the cosine of 3 pi over 2 plus, now what? 2 times 1 times pi. Good. Over 3. So the only thing that changes is my k value. Notice I have w sub 1, and so I have a 1 there. That's all that changes. Plus I times the sine of 3 pi over 2 plus 2 times 1 times pi over 3. So let's see if we can do this in our old brains, okay? If we can, I'll write it out. But if you can do this in your brain, it will help you, okay? Everybody ready? Watch. 3 pi over 2 plus 2 pi. 2 pi is the same as 4 pi over 2, right? 2 pi is 4 pi over 2. So 3 pi over 2 plus 4 pi over 2 is 7 pi over 2. Divide by 3, 7 pi over 6. Multiplied by the reciprocal. 7 pi over 6. See that? Well, now it's not so bad. Cosine of 7 pi over 6. I like that. This is becoming fun. Everybody's having fun. Everybody's got smiles on their faces. Joy. Joy for us today. Smiley faces everywhere. Look at this. I have 3 times. What is the cosine of 7 pi over 6? Negative square root of 3 over 2. Nice job. Samantha Stanley says, I look at my graphic organizer, which Mr. Gens has so nicely provided for me. Plus I times negative 1/2. Distribute. What's 3 times negative square root of 3 over 2? Negative 3 square root of 3 over 2. Now, I got to distribute that 3. What's 3 times a negative 1/2? Minus 3 halves I. No, we like to write complex numbers as two separate beasts. Yes. It's pretty. We got one more. Sure. But what I want you guys to realize is that if you take negative 3 square roots of 3 over 2 minus 3 over 2I and multiply it by itself 3 times, what are you going to get? Negative 27I. And you know what? When I saw it today and I worked through the problem, I was like, I wonder if I multiply that by itself 3 times, will I get negative 27I? I worked it out, and it works. Yeah, well, just think about foiling that out. It kind of looks kind of nasty, right? But it should work out. I mean, mathematics should always work, and it sure does. It's amazing to see how everything cancels out to just leave you with negative. I encourage you guys to give it a try. It's kind of fun. Oh, I did it. I wrote it all down. You got plenty of time over break to do it. Okay. I can't wait till your parents see the math that you're going to be working on over break. This is going to be good times. All right, I got W sub 3. W sub 3. Oh, 2. Yeah, look at you guys go. I can't go up to 3. Very good. Shame on me. Three, that stays the same because 27 to the 1/3 power times the cosine of 3 pi over 2 plus 2 times pi over 3 plus I sine of 3 pi over 2 plus 2 times pi all over 3. Okay, let's talk through it. 3 pi over 2 plus, that'll be 4 pi, right? So 8 pi over 2. So 3 pi over 2 plus 8 pi over 2 is 11 pi over 2 divided by 3, 11 pi over 6. Yes! Go to the graphic organizer, the basics of the unit circle, or go into your memory and realize that 11 pi over 6 is exactly negative 30 degrees, 30-degree reference angle in the 4th quadrant, and you know what that's going to give us. Yep, 3 times the square root of 3 over 2 plus, and sine of that is negative 1/2. So I've got I times negative 1/2. So that would be 3 square root of 3 over 2 minus 3 over 2 I. Nope, we had a negative in front. Nope. Make me. Make me, Levi. I will praise you for doing it. I will say, oh, most wonderful Jalen. How wonderful is the mathematics of your brain. That's what I will do. Hey, where'd the assignment go? Oh, no. It's on the board. Page 590. Numbers 75, 78, 80, and 83. So, I'll tell you what I told second hour. I will not, I promise, give you an assignment on Thursday, Friday, or Monday. Well, now that's what everybody else did. They laughed. And I said, well, you guys understand this. When I was in college, we would go on break. The professors would hand us a packet and say, this is your reading or these are your assignments. Please make sure that they are all completed. And we would say, what portion of this is our grade? He said, oh, it's not counted for grade. You're tested on it our first day when we get back, and that'll be your first grade in the grade book. Oh gosh, and you're like, oh, all right. So much for vacation. So I'm not giving you a packet. I'm giving you 4 problems. So you will have some work over break to do. Okay. You guys, I want to be done with complex numbers and trigonometry. This is it. We will now move on to vectors, and then we'll get to our test. So 2 sections. So find the joy in this.